All right, so today we'll start section 2. It's about how to name a covalent compound. So last chapter when we talked ionic compound, we talked about how to name ionic compound. So there's a similarity and there's also differences between the two naming systems. So we'll get into detail. It includes two parts. Similar as ionic compound, we could have a binary compound like sodium chloride, table salt, and name of a metal with a polyatomic group like a sodium sulfate. So like it's a binary ionic compound and a binary and a metal with a polyatomic group. It's similar in a covalent compound. It's a binary molecular compound, is same thing as a covalent compound, and binary acids and acids with a polyatomic group. Right. So we'll talk about the detail, the rule, how to name a ionic compound. No, I'm sorry, it's a covalent compound. From so if we have a formula, how to name a binary covalent compound, and how to name acidic solution, basic, how to name acid like hydrochloric acid and nitric acid, something like that. Right, it's so first we talk about how to name a binary covalent compound. So it's similar, like it's kind of similar to the ionic compound like sodium chloride. So first element, so in this case, first element is nitrogen. So first element is nitrogen in the formula. So the first element, we just use the name of the element. It's similar to ionic compound. The first element just use the name of element. In sodium chloride, we just use sodium. In this case, just use nitrogen. Right? For second element, in this case oxygen, we use just change the ending suffix IDE, so oxide. It's same as in ionic compound. We change the second one ending to IDE, so sodium chloride or sodium. If I have sodium oxide, the same thing as this called oxide. So ending is same, change to IDE. Right? However, in this case, so when we talk about ionic compound like a sodium oxide, it depends on the type of cation. If there's only one possible positive charge, we don't need to identify the charge. If it has a multiple possibility, like copper chloride, copper 2 chloride, or copper 1 chloride, we need to use a Roman numeral in parentheses to identify the charge for cation. However, the difference in a covalent compound, we need to use some prefix to identify the number of first element, both elements. So in this case, nitrogen had two nitrogen, so we need to identify the number of nitrogen, so we need to put the prefix di there. So the name for the nitrogen is so name for nitrogen, you need a dinitrogen. You need to identify there's 2 nitrogen there, so you put a di there. So it's di come from here, prefix dinitrogen. for the second element, you always need to identify number. In this case, only one oxygen. So we need to put a prefix of 1 mono there. So it's a monoxide. Right. So oxide is a mono, MONO. So we don't need to put a double O there. So just change to 1 O. It's only 1 O, monoxide. So the name for N2O is a dinitrogen monoxide. Right? You need to identify the number of element, but not the charge. So in the ionic compound, we need to identify charge, like copper 1, copper 2. But this one, you need to use a prefix to identify number. So it's dinitrogen monoxide. All right. So you guys need to memorize those prefixes. It came from Latin. So 2 like di, probably you guys know. 3 like tri, like a double. It often most time we call double, triple. It's a similar prefix, like mono. 4 is the tetra, like in protein structure you learn from biology. Tertiary structures. Tertiary, tetra means 4, penta, hexa. Probably you learn this from mathematics, hexagonal, something like that. The prefix 788, like octane. If you buy gas, majority component of a gasoline is octane. So OCTA, octa means 8, and 9 and 10. Right? So you guys need to memorize those prefix, name or prefix. Right here, a sample problem. So we need to name this compound P2O5. So how to name that? Right? First thing, figure out the name of don't worry about number. Just figure out the name of element. First element, just use the name of element. In this case, just use phosphorus. Second element, you need to change ending to IDE. So oxygen, you need to change oxide. Change to oxide. Right? Change ending to IDE. Right? Then you worry about this number. What prefix you need to put in front of the name of element. Right? So identify the first element, just use the name of element. In this case, it's phosphorus. Second element, you just change the ending suffix to IDE, so it's oxide. So combine this name, phosphorus oxide. So you add a prefix to the number to identify the number of each element. Right? If you check the table, so 2 use a di, like double in double. It's di. 5 is a penta. So we just add those prefix into the name. So it's di, phosphorus. It's 2 parts. Di is prefix, means 2, phosphorus, a penta, so A and O, you don't need a. So AO, you can simplify. You don't need A, just you can omit A in this case, because 2 vowels, you don't need 2 vowels. So it's a penta means 5 oxygen, and the 2 phosphorus, 5 oxygen, basically something like that. Phosphorus, 2 phosphorus, 5 oxygen, so P2O5. Right? So however, many some compound we already have traditional name, like water. We don't always call it H2O. So it's a dihydrogen oxide. So nobody can. call it dihydrogen oxide, they just call it water, like ammonia. So NH3, right? Something, those is a conventional name, common name. We already know those names before we have a systematic naming system, so we just use a common name, conventional name. So give example like water, H2O, like a hydrogen peroxide, those just we use conventional name. So we don't call it the hydrogen peroxide, we don't call it dihydrogen dioxide. We don't call it, just call it hydrogen peroxide, something like that. Right. So it's similar to the, we talk about ionic compound with a polyatomic group, like sodium nitrate. So it's sodium and nitrate. This anion part is polyatomic. It's similar in covalent compound. However, the covalent compound, there's no one nonmetal with a polyatomic, like for example, phosphor or something like NO3. No such thing. So no, there's no nonmetal with a polyatomic group. The only thing you can put in a covalent compound is hydrogen in front of a number of hydrogen, depends on what's the charge of polyatomic group. So the only thing you can have there is hydrogen. So all these things similar formula have hydrogen followed with another group. Those are acids. Right? So the acids always start with hydrogen. So acids always contain hydrogen and another element for binary compound like hydrochloric acid. So it started with simple, just a binary acid without a polyatomic group. It started with hydrogen. The only exception, so start with hydrogen but not acids, are these two, water and hydrogen peroxide. Those are not acid. Everything else started with hydrogen in the formula. They are acids. Right? So so the name of binary acids is something like that. You add hydro there. Hydro means hydrogen. Right? Start with hydro, and whatever the other element is. So in this, HCl is a chlorine. You change the ending, the suffix to IC. So it's become hydro here, means hydrogen. Chloric ending change to IC. Chlorine, INE change to IC. Then you add acid at the end. So the name is hydra, means hydrogen. Chloric, the changing from chlorine to chloric acid. So it's HCl. Acid means this compound is acid. Actually, it's all similar to the all the binary compound, no matter it's binary ionic compound, binary covalent compound, or acid, you just follow the order of element. Name of first element, then the name of second part. So in acid case, you don't call it hydrogen, you call it hydro. Right? If the second part for acid is a polyatomic group with multiple different number of oxygen, like in this case nitric acid, so the name is kind of on the following slide we'll have a name. You need to similar to the name of a polyatomic group Remember we talked about the rule how to name, like you have chlorate ion. If you have one extra oxygen, the name you need to change at a PR per in the front. You have one less oxygen called this ATE chlorate, ITE ending, you change the name, right? You have one less. It depends on name. So it depends on the number of oxygens. It change the name of the acid. So on the next slide, we'll have a table to compare the ions, polyatomic ions, and the name of acid with polyatomic group. So in this case, NO3 is the base name. So the ending is ATE, nitrate ion. You change the name to IC. If it's ITE, like NO2, NO2 is ITE. You change the name to OUS. So change nitrate to nitric. So this one become a hydrogen. So it's hydrogen. So it's hydrogen with nitrate ion, NO3 group. You change the name to nitric acid. You don't need the name hydrogen, just the nitrate. The name of a polyatomic group with the acid. Right, here's a table how to convert a name of a polyatomic ion to the name of acid. So this is the base name. So you change the ending ATE to IC, add acid at the end. If it's one more oxygen, plus one oxygen, you add per in front, ATE. The name the same, prefix per, you don't need to change. Ending to change to ending IC, acid. If there's a minus one oxygen, change the ending to ITE. So the name of acid, you change to OUS, acid. If minus 2 oxygen, that's 2 oxygen, you add prefix hypo and ITE. The same, you don't need to, for the acid, you don't need to change the prefix, just change the ending to OUS, acid. So IDE is for binary compound, like HCl. It's not for polyatomic, just for binary. So in this, for binary acid, you need to name the hydrogen, change hydrogen to hydro, whatever the name of element. In this case, chloric acid, right? The last one, basically you can separate this part. On top is the polyatomic group. The last one is for the binary, only element without oxygen. So this will give you a conversion, how to convert name of a polyatomic ions to the name of acid. Right, here are some examples. So you have, this one is 3 oxygen is the basic formula, basic name is ATE ending, you change to chloric acid. If you have one less oxygen, minus 1 oxygen, change the ending to ITE, chlorous acid. The same for the nitrate, ATE is IC acid. If it is minus 1 oxygen, change the ending to ITE, nitrous acid. Right, this is what we briefly talked about earlier. So some compound like water, ammonia, those we just use a conventional name. We don't use the systematic. Dihydrogen monoxide is quite a mouthful. We just call it water ammonia. And HCl, although it has a common name, but we seldom use this. Most time we just use hydrochloric acid. Sometimes it depends on the case. So most time we just use a convention common name. Right, here it's a kind of summary flow chart for how to name covalent compounds. So we start look at the formula. Is acid or not? If it's an acid or not. Right? So acid, the difference. Acid start with hydrogen. We just talk about hydrogen plus something, right? It's hydrogen. There's something there. Hydrogen plus something. If the formula starts with hydrogen, it's an acid. Exception we talk about is water and hydrogen peroxide. Other than that, all acids. Right? If formula starts with hydrogen, in this case, these two cases, the hydrogen, you need to follow the name of hydrogen. If this first one is not hydrogen, you follow the name covalent compound. So in hydrogen case, you need to check is it polyatomic or not. So first one is polyatomic, second one just binary, it's an element without oxygen. Then go to separate those parts. Right, basically, this is a check first element is hydrogen or not. Right? Hydrogen, yes or no. Check first element is if it's hydrogen. So separate this. Second part here, check second one is polyatomic or not, with oxygen or not. Second part. If there is no oxygen, you follow the rule of name binary acid, just name hydro, whatever the element acid. If this is a polyatomic with oxygen, you follow the rule we just talked on the previous slide. Convert the name of anion to the name of acid. In this case, SO4 is a basic name for sulfate. So it's SO3, one less the sulfite. So you name sulfurous acid. Right? If first element is not oxygen, then if the first element is not oxygen, it's always binary. There's no second group is a polyatomic, no such thing. So just the name, use the name of first element. Just name the first element, use the element name. Second element, change the ending to IDE. In this case, then you use identify number. Right? In this case, first element is nitrogen, just nitrogen. Right? For the first element, it's only one. You don't need to put a mono there. Just use the element name. Second one, you always need to identify number for second element. If it's one, just put a mono in front. If two, just put a die there. Just follow the prefix table we talked about earlier today. The exception is the first element. It's only one. You don't need normal. You don't need identifying number. Second element, you always identify number. Right. So that's all for section 2 about how to name ionic covalent compound. So we talk about the rule, name binary compound, use the formula, and how to name acids. So binary compound, you need to like NO2. We talk about no. Right? So binary compound, you need to identify number, use the element. Second element, you change the ending to IDE. First one, just use a name of element and identify number. First one, if there's only one, you don't need to identify the number. But second one is only one, you need to identify a number. What's example like CO, right? So it's carbon monoxide. Second one, you always identify number. Acid, it depends on its binary or polyatomic. It depends on it. So if the binary just hydrochloric acid is, if a polyatomic, second group polyatomic, you just use the conversion table from name of polyatomic ion to the name of acid. Right, that's all for section 2.